Good morning, happy Friday, and happy National Ravioli Day. Maybe tonight for dinner you can make some ravioli. So, before we get started, make sure you have your journal, your planner, your binder, and a pencil for today's class. In your planner, write down the homework that's due on March 24th, which is Tuesday. Homework is F equals MA problems. After you've written that down, go ahead, open your journal to a new page and respond to the following prompts. How are you doing physically? What types of movement are you getting each day? I know it's hard being cooped up in front of the screen all day, so what sort of things are you doing to move your body? And then for the second prompt, briefly describe the video that you commented on using Flipgrid. So this was part of the homework assignment. Just describe a little bit about the demo that the other student did. And remember, you can always pause if you need more time to journal or you just need more time in general. And then just press play when you're ready. So let's do a little bit of review. So last time you were entering data from the lab that we did in class last week, and it was about a cart that was pushed using a force from air, from a ball pump. Now, most of you were able to easily write your group numbers and think about it and your data, but I really wanted to focus on some of the questions. So that first question, explain the effect mass has on distance traveled. So a lot of people answered that. They said that with a higher mass, right, as you added more pennies, the cart didn't travel as far. But not as many people explained the second part of that question. Does your data support Newton's second law? So remember that Newton's second law is force equals mass times acceleration. So in that, if you want the cart to go accelerate the same, you're going to have to push with a higher force each time you add more mass. But you use the same ball pump every time, so you weren't able to add more force. Therefore, your acceleration went down. So skipping a couple of those questions and moving to the last question. So there were a bunch of different answers of how do Newton's second law of motion affect astronauts aboard the International Space Station. There were a couple of things that you could have said. One thing is that, remember, there's not a lot of gravity, and so there's not a lot of friction. So when you push on an object with a little bit of force, it actually goes quite quickly, just like we saw with the chapstick. And based on the experiment and on the video we saw, that we were able to see that Newton's laws do work in space. They do work on the International Space Station. Another answer that I got was, in order to for a rocket to launch into space, there needs to be a huge force because the rocket has such a huge mass. So that was another acceptable answer. Okay. So for your homework, you posted on Flipgrid, which was awesome. I was able to watch some of these, and I am looking forward to watching the rest of them as they come in. And I noticed there was a theme. A lot of folks chose to do something similar to my initial video, which was great. I love to see all your variations. But I wanted to show you some other options. So here's a video that I made it.
Hello, I'm back. So I saw a lot of your videos, which were awesome. And what I noticed was most of your videos had a similar thing like me. You had two different masses, the same amount of force. The heavier thing is going to go farther or the heavier thing is going to go slower and not as far. And then the lighter thing is going to go farther and faster. So Newton's second law, you can do some other things with it. So what I'm doing here is I'm going to actually try to get these two different masses to go the same distance. All right, so what I need to change instead is I need to change the amount of force that I put. So instead of hitting them with the same force, I'm going to hit the light thing, very light, and then I'm going to hit the heavy thing as hard as I can. So you see that I tried to get them to go the same distance and the same acceleration by just changing the amount of force. Now another variation of Newton's second law is, let's say we have the same mass. So right here, I have two marbles, the same exact mass. If I hit them with the same exact force, they're gonna go the same distance and the same acceleration. But let's say I take one and I hit it with a larger force, let's see what happens. Versus this one, I hit with a smaller force. All right, so Newton's second law actually can be any of those three scenarios. You could change up the force, keep the mass the same. You could change up the mass, or you could make the masses different and change the amount of force. So any of those work, and I love watching your videos. Thank you.
So the last time we took notes, we wrote about Newton's second law of motion. An object acted on by an unbalanced force will accelerate in the direction of that force. So we've looked at some examples that if the force increases, then the acceleration will increase. And if the mass increases, then the acceleration will decrease. So now you're going to need to take out your notes, and I'm going to show you a short video of how to calculate for force or mass or acceleration in a bunch of practice problems.
All right, so Newton's second law. Newton's second law. So we've been learning a lot about Newton's second law, but there's actually a couple of different ways you can use this to calculate. So we've already really focused on F equals ma, right? And just as a reminder, F is the force in newtons, so that's F. M is the mass in kilograms. And A is acceleration in meters per second squared. Okay, so that is not new to us. Let's say, though, I get a problem and it asks me to figure out what is the force for a mass that has 10 kilograms and an acceleration of 2 meters per second squared. Okay, so what would I do in that case? Well, let's see. So I'm going to rewrite the equation. F equals m times a. I don't know what the force is, so I just write F. M, the mass is 10, so 10 times acceleration is 2. The force is 20 newtons. That's my answer. Okay, so I kept the numbers pretty easy just so you can do it. And you might do it in your head, but for the beginning when we're learning this, please write this out. So keep all of this in your notes. Let's move on to another scenario. So let's say I have a scenario where I know the force, it's 100 newtons. I don't know the mass, but I do know the acceleration is 4 meters per second squared. In this case, it's not super easy to use the original formula. So we're gonna kind of rearrange that formula to make it mass equals force divided by acceleration. So now that I have that, I'm trying to find the mass, so I leave that as m. I have force is 100 and divided by 4. So I can do that in my head. Mass is 25 kilograms. Great. So sometimes you are given the force and you're given the mass, but you're not given the acceleration. So this is the third variation of Newton's second law, is acceleration equals force over mass. So let's say a scenario, I know my force is 90 newtons. My mass is 3 kilograms. And I'm trying to solve what is the acceleration. So I don't know the acceleration, so I just write A. But the force I know is 90 divided by, the mass is 3.
that tells me that the acceleration is 30 meters per second squared. So make sure you have this in your notes because this will help you on the practice problems and will help you in your homework. So now that you've learned how to use those three equations, we're going to do some practice problems. And the practice problems are on Google Classroom. So there's two parts to this. You need to see the problems and then the answer sheet. So if I go to Google Classroom, there's one document called Newton's Second Law Practice Problems. So in this, there's two parts, and you're going to show your work, write down the equation you use, and don't forget to include units. And then I recommend doing it on a separate piece of paper, but if you have a printer at home, you can print this out, do it right there, and then here's your answer sheet. So you're going to write, for problem 1, the equation that you used, the answer. You're going to insert a photo that shows your work from the first 10 problems. It gives you a little hint. You can do insert and image and go right to, go right to your camera, and it will just do your webcam. And then the same is true for the second bit. So, and then at the end, you'll just rate how difficult they are, and you'll go ahead and turn it in. All right, so once you finish those problems, go to Move and Break.